Good morning again. Well, I had somebody who I met in a restaurant there a couple of days ago. They were studying for a test, college level, Ohms Law and applications, with a little bit of Kirchoff's rules as well. So I saw a video of their professor, teacher, call them what you want, and it was awful. So I decided to do a little quick review for that person and for anybody else who wants to listen or look. So basically Ohm's Law deals with current, voltage and resistance. Alright, what does that mean? Before you can get a current, you need a conductor. And a conductor, in the case of electricity, is usually something metal. But let's just deal with gravitation first. Now suppose I put some water here at a certain height h above this level here. Let's call it this level. This height here, actually this height here above this level. Now, there exists a potential difference. What's a potential? The potential energy per kilogram. In other words, for 1 kilogram, the potential is the number of joules per kilogram and the amount of work we needed to raise 1 kilogram through a certain height h. Height h. Now there's a potential difference between this one and this one. If this called h equals 0, the potential difference is actually just GH in this case here. The potential energy for all the material up here, all the water up here is mgh, where m is the total mass of the water. This is only general, I'm not going to do all the details, just to give you the idea. Now this is the conductor connecting the two tanks. Two tanks, one is empty. Now here is a valve. If I open the valve, then the water can flow. It can flow at such time as all the water gets down here and none is left up there. And now the potential difference has resulted in a current going from here to here, and this is a current of mass. So we talk about joules per kilogram. As being units of potential in the case of gravitation. Now let's go for electricity. In the case of electricity, we have a battery. High potential, lower potential. Now if I connect up the two ends of the battery, this is the same as the tube that was connected to two tanks. All the water will flow from the end of this one to this one, and it'll short circuit the battery so that no charge will be left in the battery very quickly. This is an infinite conductor. Now, an ammeter counts the current. What does that mean? Counts not the number of kilograms going past or through it per second. An ammeter counts the number of coulombs of electricity. Now, if it wasn't enough to confuse you, amps is current. An ammeter here is a current counter. It counts the number of coulombs passing a point per second. 1 coulomb of electricity, 2 coulombs of electricity. That's about 1 coulomb per second. If we have 1 coulomb per second passing through the ammeter, we say we have a current of 1 ampere, or 1 amp for short. If we have 6 coulombs passing through the ammeter in 3 seconds, we have a current of 6 over 2, or 3 coulombs per second, 3 amps, 3 amperes. I is the symbol for current. And in symbols, I is Q over T. Q is the number of coulombs, T is the number of seconds. C is the units, S are the units also. And the units of amps, whose symbol is I, is coulombs per second. That's the way the units work. Now the potential difference between these 2 points is measured in joules per coulomb. Because a minute ago we had kilograms per, joules per kilogram in the gravitational case for potential and potential difference. But in the battery, it's joules per coulomb, which are given the name volts. And in symbols, volts is joules per coulomb. So we could have a joule per coulomb difference of 6. 6 what? 6 joules per coulomb. 6 volts. That means going through that battery or falling through that potential difference, every coulomb of electricity picks up 6 joules of energy. Okay? If we had a 12 volt battery, every coulomb going through that potential difference of 12 volts picks up 12 joules of energy. Volts is joules per coulomb. And that's all you need to remember from now on. I, current, is amps. Amps is coulombs per second. Volts is energy per coulomb. Joules is energy, joules per coulomb. Excuse me. The only other thing up on the board is resistance. So volts has a symbol V, and units of joules per coulomb. I is a symbol for current, whose units are amps. Amps is coulombs per second. And resistance, we'll give it a symbol R, and we'll talk about what it is in a minute. Okay. In this particular circuit here, there was nothing stopping the current from moving. Now a voltmeter goes across a potential difference. You think of a voltmeter as going like that, it measures a potential difference between these 2 points. An ammeter, the current flows inside, in one side and out the other. An ammeter. Different things. Ask for a reading on an ammeter. The reading on the ammeter will read your current in the circuit. Ask for a reading on the voltmeter. The voltmeter will read the potential difference. This one will read 6 volts because it's a 6 volt battery. We put a voltmeter here. I will get a reading of V equals 0. There is no potential difference between these 2 points on the conductor. Here's a bird on a wire. Everybody knows you can put a bird standing on a wire and he doesn't get electrocuted. That is because there's no potential difference between the 2 points where his body touches the wire, even though it's carrying a current. There's no potential difference between here and here, so no current flows. This is at, let's say, 100 volts, and this is at 100 volts. There's no potential difference, so no flow of current. There is something else, though, that I didn't tell you about. All right, so let's continue now. This circuit here, let's get rid of, we don't need the voltmeter, it's there. So now let's introduce something to slow down the current. a resistance. Now, resistance could be a light bulb. And when you slow down something, it's like pulling a rope through your fingers, your hand, energy is going to get lost. You're going to have to absorb. If you go near your brakes of your car, you're slowing your car down, the energy lost by your car coming to a slower speed or even to halt has to go somewhere. Well, it goes into the discs of your brake that get real hot, right? Now, same is true for electric current. You take away some of its energy, it has to show up somewhere. In the case of a bulb, it shows up as heat or light, okay? So a bulb creates a resistance, absorbs energy from the current, actually from the battery, and shows up in the form of heat or light, a bulb. So a bulb is a resistance, this could be a bulb. So we'll say it has a resistance R, all right? Now, in the case of our water system, that would be the same as adding rocks to our pipe. And if I add more rocks, and more rocks, and more rocks, and if the rocks are all the same size, double the resistance, triple the resistance, quadruple the resistance to slow the water from getting down to there out of shot, okay? And of course the rocks get a little bit warmer, see, because they're absorbing the energy. In the case here, we have a resistance. Now, Ohm says that the current in a circuit, right, current is inversely proportional to the distance. Now, what that means is this. The more resistance you add, you don't get more current for a certain voltage. If you double the resistance, this one here, you have the current. Double the resistance, have the current. 3 times the resistance. Three times the resistance, you get 1/3 of the current from the same battery. Doesn't that make sense? Yeah. So you don't really think of V equals IR. Well, you could, because it's a straight line, so that the V and the R, the I, it's a straight line graph like that, but it's more logical to think in terms of double the resistance, halve the current. Now we can define these units of R. So the units of R, of resistance, are going to be volts per amps from this equation. Now, I don't like the little triangle people use. I'll show you how to get away from that in a minute. Multiply by reciprocals to solve for things. Ri equals V, or V equals IR. Take the same equation. Let's see which one we want. Divide both sides by I. These cancel. So that our resistance R is V over I Now V is volts and I is amps, and we'll call these guys ohms. And that's the Greek letter omega, the symbol for ohms. But let's put in the other ones. Volts are joules per coulomb, and amps are coulombs per second. So another way of writing the units of R, or ohms, is joules over coulombs times coulombs over seconds. And dividing by reciprocal is the same as joules over coulombs times seconds. Let's see if I got that right. Joules over coulombs times seconds over coulombs. Is that right? All right for now. Yeah, I guess so. Alright, so doesn't matter, it's still volts over amps for now, that's definitely correct. So now we have three things. I'm going to clean the board and summarize everything. I just wrote it down, but that's the same equation. It doesn't matter. It's only one equation, written three different ways. There is a joke about some professor saying we have three equations in electricity and lists those three equations, but it's only the one. This is it. V equals IR. So, volts is joules per coulomb, I is coulombs per second, that's amps, and resistance, ohms, is volts per amp, okay? And that's all we've got. Now let's add another resistance to the circuit. Now remember what we said. We double the resistance, we have the current. Let's put in an ammeter. Now what's the reading on the ammeter? The reading on the ammeter is the current. Now let's say that the voltage is 12 volts and that these two guys are 2 ohms and 2 ohms. We have two resistances in series. That's one after the other. Suppose this one is 2 inches long and this one is 2 inches long. Put them together. It's the same as having a 4-inch long resistor. So that the total resistance in the situation where the resistances are in series is just the sum of the resistances. So that the total resistance in this circuit is 4 ohms. Now that the voltage in the circuit, in this case, is 12 volts. If we're asked to find the reading on the ammeter, that is going to be the I. And what is it going to be? Well, I is V over R. Now in this case here, the V is 12 volts, and the R is 4 ohms. Now volts over ohms you can show is going to be amps. You can show that using the last one. I'll keep it short for now. So in this case here, 4 over 3 is 4 amps, 4 over 3 amps, so that the reading on the ammeter is 3 amps. Okay? And so on and so forth. If I had a whole string of resistance in, well, all different numbers, it wouldn't make any difference. It just makes the problem longer in terms of what you do with your calculator. But that's the same thing. So resistances in series, you add them. Series means one after the other after the other. Now let's look at a different situation. Okay, so I put them down just for your sake. Sometimes you see a circuit and the resistances look like this. We could do the same circuit. Now, we put the resistance looking like that, but to get a clearer picture of it, I want to draw it a different way. Very often, drawing the circuit in a clearer way gives you a better way of thinking about it and looking at the problem. These are said to be in parallel. What does that mean? Well, it means like this. We have our 12-volt battery. Now we're going to stick an ammeter in there. And make it look like this, actually. This circuit is exactly the same as this because we have one path dividing into two, going back into one, and continuing. One path dividing into two, going back to one path and back to the battery. Okay? We're asked to find the current in the circuit, find the reading on the ammeter. What is the reading on the ammeter? Well, we go, I is going to be V over R total. Okay? So we need the total resistance in the circuit. Okay, this is the way we do it. Alright, so this is the way it works. We have Yankee Stadium. The crowd is going out. And we only open up one door. And 10 people can go out the door per second. So that's 10 people per second going out that one door. We have a current of people, 10 people per second. The 10 amp, if amps are for people per second, 10 people per second going out the door. How do I double the current? Open up another door, 2 doors. Another 10 people can go out that door per second. Now we have 20 people going out the Yankee Stadium per second, out 2 doors. How do I triple it? 3 doors. 30 people per second, 4 doors, 40 people per second, and so on and so forth. That's when the doors all had the same width, same capacity, 10 persons per door. I could open out a different door, a 10 person per second door, and a 20 person per second door, and improve things even better. So we don't want to get a headache thinking about it too much. What we'll do is we'll say I total splits up into 2 currents, I1 and I2. So the current goes this way and it splits up 2 ways, but the total current is going to be V over R total. Well, I1 is going to be V over R1. I2 is going to be V over R2 because both resistances see the same potential difference. This wire is talking to both resistances equally. Each one receives the same potential difference, so the same V exists. So I can take out a common factor here of V because it's the same for both expressions. V over R1 and V over R2 is the same as V times 1 over R1 plus V over R2. But that is the same as V over R total is that. So I divide both sides by V, and I can say that 1 over R total is 1 over R1 plus 1 over R2. So in this case here, it's going to be 1 over 2 so therefore R total is 1, but that's 1 over R total. In this case here I made it too easy. I made R total to be equal to 1, so I can go that I is V over R total And 12 over 1 is 12 amps. But let's do it differently this time. Let's use different numbers, and the whole thing still works out the same. Now this time we're going to open up 3 gates in Yankee Stadium, but they're different widths. This one lets out 2 people per second. This one lets out 4 people per second. And this one's going to let out 6 people per second. Actually, I make it 3. Actually, I choose those numbers just for the heck of it, right? Okay, so let's work on that. We're asked to find the current in the circuit. The circuit is going to have electricity going around it through the ammeter, and back here going to have I amps. We need to know what is the I. Well, I is going to be V over R total. And we have a formula. R total is going to be the sum of all the reciprocals added up. 1 over R1, 1 over R2, 1 over R3. Doesn't matter what they are. So in this case here, it's going to be 1 over 4 plus 1 over 3 plus 1 over 6. And it's going to have units of reciprocal of ohms. So now we want to add these fractions. Well, we choose a common denominator. 4 and 3 and 6 have a common denominator of 12. One-fourth is the same as 3/12. Multiply above and below the line by the same thing. You don't change the value of the expression. 1/3 times 4 over 4 is 4/12. 1/6. It's the same as 2 over 12. So now I can put in the numbers here. 3 plus 4 plus 2. 4 and 2 is 6 and 3 is 9. We get 1 over R total is 3/4. Here's where students make a mistake. They put that into the equation. Well, you can put it in like that, but R total is 4/3. So you need to have that one. This is already 1 over a reciprocal, so we can use that straight away. But I'll just keep things clear. 24 volts over 4/3. 24 times 3/4. 3/4 is 24. 1/4 of 24 is 6. 3/6 is 18. 18 amps. Okay? I'll let you get your heads around that. Now we could get more complicated. We could ask, what's the reading on that ammeter? Call it ammeter 2. I is just going to be V over R2. V is 24, and R2, which one? R2 is 4. And we get 6 amps. We could ask, what's the reading on this one? So A3 is going to be 24 over 3 amps. 3 into that goes 8 times. And now I go to the third one. Call this I4. We put an ammeter in here. Well, I'm calling this R4 for now, but it's the 6 ohms. 6 into 24 goes 4 times. Now we have to notice something. All the current here is 18 amps, and it splits up into 3 different doors. No current disappears. Current is conserved. That will lead up to one of Kirchoff's rules coming up. The current goes in must be the current that comes out. So if 18 amps go in here, 18 amps have to come out of here, right? But it gets split up 3 different ways. 6 goes to the top one, 8 amps to the second one, and 4 to the bottom. 4 and 8 is 12, and 6 is 18 amps. So it works out fine. That's enough for this class.